This is a short video about a very special class of carboxylic acids. Carboxylic acids with a carbonyl on the beta carbon. Why do we call it a beta carbon? Well, the first carbon over is alpha, the second is beta. So this particular acid has two carbonyls. A ketone is a ketone and a carboxylic acid. The ketone carbonyl is beta to the carboxylic acid carbonyl. Now, what's interesting about this molecule is if you heat it up, it'll undergo a particular deconstruction. How does this work? Well, I need to redraw the molecule. I want to get the single bond up on top, so I'm going to convert this to the double bond, this one to the single bond, and I'm going to explicitly draw in the hydrogen. Now, this is important because this is actually the stable form of this molecule in the first place, because it forms this nice internal hydrogen bond between the OH group of the acid and the carbonyl of the ketone. Now, the interesting thing is if you heat this molecule up, it'll self-destruct. And it'll self-destruct in a very interesting way. What actually happens? Well, there's a rearrangement of the electrons. The carbonyl of the ketone, that double bond reaches out, grabs the proton. The OH electrons come down and form a new double bond. And then this single bond moves over to form a double bond. What do we get when we push the magic button? Well, we get carbon dioxide. So we have decarboxylated this beta keto acid. And we've made an enol. Now, enols, of course, are tautomers of ketones. And we can get back to our ketone. This is not a stable molecule. This will tautomerize. The hydrogen is going to pop off the oxygen and go over to the carbon, moving the double bond. And this is going to happen very readily, where there's no way we can stop it. So it's going to do is very fast tautomerization, and we're going to end up with our ketone. So the beta keto ester, beta keto acid, has decomposed to give carbon dioxide and an enol, but that enol rapidly tautomerizes to get a ketone. So we get net the keto acid goes to the ketone and a mole of CO2. Neat reaction.